Hey everyone and welcome back. So in the last video we solved majority element 1 and majority element 2 using Boyer-More voting algorithm. Okay, so maybe there are different types of problem available where you have to find majority elements. You can use that algorithm. So today we are going to solve one more problem which is assign cookies, and it is easy problem from the Leetcode. And in this problem we are going to use array, two pointers and greedy. So I already explained what is the two pointer and what is the greedy. So greedy is basically our algorithm where we try to maximize our profit, and two pointers is a technique where we use two iterators simultaneously to solve a problem. So let's see what is the problem. So we have given two array S and G. This array contains sizes of cookies. Means you have three number of cookies here. 1, 2, 3, and the size of every cookie is 1. So the first cookie has a size of 1, or you can take like this: your cookie first have a size of 1, and the cookie of 2 is having a size of 2, and the cookie 3 is having a size of 3. So the bigger the number, the bigger the cookies. So we have a cookies with the different sizes, and we have given a different array G, which is a greedy factor. So now in this problem you have two childrens based on number of greedy factor. So the size of the greedy factor is 2, so number of children is 2. So you have two childrens, okay, and both of them having a greedy factor of 1, right? Greedy factor basically is that they will be only satisfied if they have something with the size of 1. Means here we have three cookies, 1, 2, 3, and one is having 1, 2, 3, and we have here two children and both of them having greedy factor of 1, 1. So if we assign this one cookie to this children, and it also having greedy factor of 1, so this children will satisfy, right? Now the one cookie we used, now we have remaining cookie 2 and 3. So if we assign this cookie to, he also will satisfy, right? So the maximum number of children we were able to satisfy is 2. So 2 will be our answer. So you have given a different size of cookies and you have childrens with the greedy factor. You have to assign the cookies such that maximum number of children will be satisfied. So let's take another example. So we have greedy factor of 1, 2, 3, and we have cookies of 1, 1. Okay, so in this case this children will be satisfied with the single cookie. Will this children will be able to satisfy with this cookie? No, right? Because he has a greedy factor of 2, so he needs a cookie with the size greater than equals to 2, but we don't have any cookies with the size greater than equals to 2, so the only one children will be satisfied. So let's take another example. So we have G equals to 1, 2, S equals to 1, 2, 3. Okay, so we can take also like this. This is size 1 of the cookie, this is size of the second cookie, or this is size of the third cookie, and the children also will be happy with this small amount, and this children will only happy with this amount. So we can assign this cookie to this cookie, he will be satisfied. We can assign this cookie to this cookie, he will be able to satisfy. So we have only two children, so our answer will be 2. Okay, so let's take one more example. So we have something like this. Okay, so if we draw, you have this much grid having 2, this one having 3, and this one is 1 size, this one is 2 size, and this one is 3 size, right? So we can assign this cookie to this cookie, he will be satisfied, right? We can assign this cookie to this cookie, he will be satisfied, because he has only one greed factor and he is getting more than his greed factor, so he will be satisfied. You can think like that. If you are supposed to get money of 10 rupees, right, but you able to get 20 rupees, you will be able to satisfy, right? If you are given 5 rupees instead of 10, you won't be satisfied. So you can say the more you get, the more you will be satisfied. So in this case, children's wants large size of cookies. They will be satisfied with the same size and the larger size, but they won't be satisfied with the smaller size. So in this case, our cookie size is 2 and his greed factor is 1. So cookie size is greater than the greed factor, so he will be satisfied. Now similar case with this, so he will also be satisfied. Okay, now we have one children remains and we don't have any more cookies, so we can say we satisfied 3 children, 1 2 3. Okay, so basically we just have to assign the cookies such that our cookie size is greater than equals to greed factor, so they will be satisfied, right? So you must have observed one pattern here, that we are running loops in both the array and trying to assign the cookies. If we are able to assign the cookies, we will increase our count, because they only want number of children satisfied. So if we look at it, we are here, so we can take I, we can take here j. So if you compare this, s of j greater than g of I, right? So the condition is true, right? 1 greater than equals to 1, so we can increase our count 1. Now we will move our ij to the next element. So here you can see 2 greater than equals to 2, so our count will become 2, right? So now if we move our pointer, our I will end here, so we will stop our loop and we will return this count, right? Okay, let me write it. So we have g equals to 1 1 2 3, s equals to 1 2 3. We have 2 pointer I j. Okay, so s of j should be greater than g of I. This is a size of the cookie and this is the greed factor. So initially we are at the first index, so 1 greater than equals to 1, condition true, so our count will become 1. You can say our initial count was 0. Now we will move to the next index. Now in this case, our value of sj is 2, our value of g of I is 1, so condition is true, our count will become 2, right? Now let's move to the next index. Our value of sj is 3, our value of g of I is 2, so our count will become 3. Now let's move to the, here you can see our j reached the end, so we cannot compare, so we can stop our loop and our count will be 3. So for doing this, we have to declare 2 variable I and j, which they will be starting from the 0th index, and we also declare size of the arrays, because we are iterating, so we do need the sizes of the array. Now we will run a loop if I less than n and j less than m. So if one of the indexes reach the end of the array, we can stop our loop. So in this example, our j stops first, so our condition here becomes false. So this is true, this is false, and this is end, so overall condition will be false. So condition is false, then our loop will stop. Now we just have to compare if my s of j greater than equals to g of I, means my cookie size is greater than equals to greed factor of the children, then I will increase my count plus plus. So here we also have count, and I will move my I and I will move my j here. Now here you may be thinking, why we are doing I plus plus in the if condition and j plus plus outside the if condition. So if you look at this example, and if we try to iterate from I and j here, so the first value 1 greater than 2, no, it won't satisfy, right? Now let's move over I and j. So first wasn't satisfied. If I moved here I and j, so in this case also 1 greater than 2, no, then I will move again. In this case also 2 greater than 3, not satisfied, but we can still assign this cookie to any one of them, right? So the answer should be 1. So that's why we are only moving I when one of the children is satisfied. So you can say all children are standing in the single line and we have to satisfy from left to right, and we will not move until we will satisfy all the children from the left, right? That's why we are moving our I in the if condition after satisfying the previous, and we will move our j continuously, because if this cookie is not able to satisfy this both of them, so this one won't satisfy this one also, right? So we will move to the next. So that's why we are moving j outside the if condition. So even the children is satisfied with the cookie or not satisfied with the cookie, we will still move our j, because if j is not able to satisfy previous children, then we will move our j, because it won't be able to satisfy any more upcoming children. Till now we have took all the sorted arrays. If you look at the all the examples, we have took all the sorted arrays, right? So the greedy algorithm we are using in this problem, we need a sorted arrays. Okay, so we will sort this array while writing a code. Okay, so this is our problem, this is our greed factor, and this is our size of the cookie. So one size you can assign to this first children, and the another one size you cannot assign any of the children, so you will be having only one answer. Similarly here you have greed factor 1 and 2, and the size is 1 to 3, so you can assign 1 to these 1 2 children, so your output will be 2. So let's first declare the size of the g and the size of the s. Also let's declare count equal to 0, int I equal to 0, int j equal to 0. Then we will run our loop. If I less than n and j less than m, and if our s of j is greater than g of I, then we will increase our count plus plus, then I plus plus. Okay, let's do a j plus plus here itself, so you will be able to understand what the problem we will be facing. So here return count. Okay, so in this example I took I and j simultaneously in the if condition. If both the children are satisfied, then we will move I and j. So let's try to run this code. Okay, here should be m. So here you can see it is giving me a time limit exceeded. So if we talk about the time complexity, it is still in the wig of n or wig of m. It will depend on the size of the array. So we can say it will run a minimum of n and m. So it is 10 to the power 4, so it will run without problem. But what's happening, that if there isn't any cookies which we cannot assign to the children, the loop will not continue, because all the updation variables are in the if condition. If condition is not executing, there is no other condition to execute. So that's why we have to iterate regardless of the children are satisfied or not. Okay, so the first and second test case got passed. So let's try to submit it. Here you can see till now we were taking all the sorted, but in this case they haven't given the sorted arrays. So to avoid this, you have to first sort your array, so you will be able to apply this concept. So now this program got accepted. Okay, so you just have to remember two things. First, you have to sort both the arrays, because we are using greedy, so we are trying to maximize the profit. And the second is you have to satisfy maximum number of children. So this I is iterating over the greed factors, so we will not move until we will satisfy the children, and j will move regardless if children is satisfied or not. And the time complexity will be big of min of n comma m, right? Because our loop is stopping where one of the arrays is ending. So the array which is having size smaller than the other, that one is ending first. So we can say min of n and m. So which one is smaller, we will end our loop, and this will be our time complexity, and the space complexity will be 1, because we are not using extra space. And that, okay, this time complexity is for this loop only. We also used sort function, so for the g it will be n log n, right? For this s it will be m log m, right? So if we write total time complexity, it will be n log n plus m log m. So this will be our overall time complexity, because we have to consider these functions also, because we are using sorting function which takes n log n or m log n. So in the next video we will solve more problems. Until then, thank you everyone, have a nice day.